everybody. In this video, we're going to be talking about permutations. So take 3 deep breaths and let's make this math easy. Okay, so in our last lesson, we talked about how we can use choice trees to help us figure out the number of possible outcomes. And permutations are a special case of what we talked about last time because permutations apply when you're selecting your choices from the same group of things, and the choices that you make early on affect your later choices. So, for example, in this problem, the question asks us how many 2-letter words can you make with these Scrabble tiles? So words is in quotes because we're going to allow any combination of letters to count as being a word, even if it's not an English word. So what we're doing here is we're essentially choosing 2 letters from these Scrabble tiles. So we have 2 events or 2 choices that are happening, and so our choice tree would have 2 layers to it. And the first layer would tell us that we could choose any one of these 5 Scrabble tiles to start with. So we would have 5 possible outcomes for our first choice. We could choose the letter E, the letter D, the letter X, the letter N, or the letter O. Now, the thing that's different about permutations compared to what we did last class is that your first choice impacts your second choice. Because if I choose the letter E from this group of Scrabble tiles, I can't choose the letter E again because I don't have 2 E's in my set of Scrabble tiles. And so that means that my second choice only has 4 options because I could choose the letter D, the letter X, the letter N, or the letter O. So I only have 4 options branching off of the letter E. And for the letter D, I also only have 4 options, even though they're different ones, because I could choose the letter E, since if I chose D first, E hasn't been chosen yet. I couldn't choose the letter D again, though, because I already chose it for the first one. I could choose the letter X, or the letter N, or the letter O. And then if I had chosen X first, I could choose E, D, N, or O for my next one. And then same thing with the letter N. I could choose E, D, X, or O, but I couldn't choose the letter N because I had already chosen it. And then for my last set of the choice tree, if I chose the letter O first, I could choose E, D, X, or N, but not the letter O because I had chosen that one as my first one. So mathematically, the way that we can calculate the number of outcomes is very similar to what we did last time, because we would say there's 2 events, so I'm going to have 2 numbers that are multiplied together. The first event had 5 possible outcomes, and the second event had 4 possible outcomes, because whichever letter I chose first was not in the group of the letters that I could choose second. So notice that the number of options branching off of each of these is 4, even though the actual letter options vary depending on which one you chose first. The number is consistently 4. And so we have 4 options for our second choice. And so we would multiply these together to find the number of total 2-letter words that we could make with these Scrabble tiles, and we could find that there's 20 of these 2-letter words. And this is basically how permutations work. It's the idea of your first choice impacting your second choice, and your second choice impacting your third choice, and so on. So let's do another example of this, and let's do one where we definitely don't want to draw the choice tree for it. So in this problem, it says, how many ways could you choose 6 songs to record on a cassette tape if your favorite band has 28 songs available for your selection? So I specifically chose a cassette tape because in that case, like the order of the songs matter, and we'll talk more in our next lesson about why this is important. But if I wanted to choose 6 songs, that means I have 6 events. So if I were to draw a choice tree, my choice tree would have 6 layers to it. And the layers of those choice trees would have, or that choice tree would have a lot of different options, because the first layer would have all 28 songs branching out. So if you can imagine, you'd have this huge choice tree with like 28 songs all listed out, and that's just choosing the first song. Then your second song that you would choose, you would have 27 options branching off of each of those. And the reason it's 27 is because you wouldn't want to put the same song on the cassette tape twice. So you would, like whatever song you chose for your first song, you could put any of the other songs on as your second one. And then your third choice would have 26 branches branching off of each of those. And basically this choice tree would be huge. So instead of drawing out the choice tree, we're just going to do the mathematical calculation. And we're going to say, okay, we have 6 events that are happening here because we're choosing 6 songs. And our first song has 28 options of what it could be. Our second song has 27 because we don't want to put whatever song we put on first as our second song. And then our third song could be any of the 26 remaining songs. The fourth one could be any of the 25 remaining songs that we haven't chosen yet. And then the fifth one could be any of the 24 songs that haven't been chosen so far. And the last one would be any of the 23 songs we haven't chosen so far. So this pattern of decreasing by 1 is consistent whenever you're calculating a permutation. Because the first choice that you make impacts the next one, which impacts the next one, and so on. So if we calculate that out, we can do 28 times 27 times 26 times 25 times 24 times 23. And that is a very large number because it is 271,252,800 possible ways you could choose 6 songs to record on a cassette tape. So thank goodness we didn't draw that choice tree, because that choice tree would have like over 270 million branches in it. So that's the power of using this mathematical way of figuring out the number of possible outcomes instead of having to draw out the choice trees. But the reason this mathematical process works is because of the structures that are present in the choice tree. Because the 28 is telling us you'd have 28 branches, which each branch out into 27 branches, which each branch out into 26, and so on and so forth, until you have 6 layers of branches. So that's how you would do a problem like that one. So I want to talk really quick about the permutation formula so that you can understand how to generalize this. So the number of ways that you can choose k objects from a group of n objects is n to the k falling. So if we use that last example that we just did, where you had 28 songs and you were choosing 6 of them to put on a cassette tape, the 28 is the group of objects that you're choosing from, and the 6 is the number of objects that you're choosing. And so the way that you would write this out using the formula is that it would be 28 to the 6 falling, which is basically the calculation that we just did, because it's 28 times 27 times 26 times 25 times 24 times 23. So this 6 falling thing is telling you how many numbers to multiply together, and the falling part is telling us that you're decreasing the number each time. Because a normal exponent, like if you didn't have that line underneath it, would be like 28 times 28 times 28, 6 times. And so we use this notation of a falling, I think of it as a falling exponent, but technically it's not an exponent at all, because you're not multiplying the same number by itself multiple times. But we use the notation that looks kind of like an exponent because it's got a similar idea as an exponent does. So that would be how you would calculate it for that first example, or that example that we just did. And we could also use this notation to represent the first example we did, where we had 5 Scrabble tiles and we were choosing 2 of them to make those 2-letter words. And in that case, the way we would think about it is there's 5 outcomes, or 5 Scrabble tiles that we could choose from. And then we're choosing 2 of them, so there's 2 events. So it's going to be 5 to the 2 falling, which would be 5 times 4. And that gave us the 20 possible outcomes that we found using the choice tree before. So you can use this notation to help you think about it. You may also want to write it out so that you remember what it means, and also to help you multiply it when you use your calculator. There is a shortcut that you can use in your calculator though, because permutations are used often enough that they programmed it into the calculator to do this for you. So if you wanted to type in that first one into your calculator, the way that you would do it is you would type out 28, and then in my calculator, the permutation button is in the probability menu, so it's this button right here. And then when you click on the probability menu, there's 3 options. There's NPR, NCR, and the factorial button. And so NPR is the one that stands for permutations. So you would hit enter on that, and you get 28 NPR, which basically means we're doing a permutation where we have 28 objects, and then we want to choose 6 of them. So you do 28 NPR 6, and then when you hit enter, you can see that 271 million number that we found on the last slide. And just to show you how to use that calculator button again, you would do 5 probability button, then NPR, because we're doing a permutation, and then 2 to calculate the second one, which gives us that 20. So this NPR button is basically just a shortcut so that you don't have to type out all of the multiplication. But on your assignment, at least for today, I would still like you to write it all out so that you remember what it means. I'm fine if you use it, the calculator button, to actually calculate what the number is, but I want you guys to write out what the multiplication means, because that will help us with later lessons. So with that information, why don't you guys try these 3 problems on your own? Pause this video and then restart it once you finish them to see how I would solve these. Okay, so for this first problem, the correct answer is 30,240 different ways that you can get a 5-digit PIN. For the next one, we have 12,144 ways that you could choose a president, vice president, and secretary from a group of 24 people. And then for the last one, this number is really big. You get 57,657,600 ways you could choose a 7-day menu from the 16 meals in your freezer. So those are the answers that I got when I solved these. If you got anything different, you can skip forward to the timestamp shown on the screen to see how I solved them. And if you got the same numbers as me, great job, and you can stop watching the video here. Okay, so for this first one, the question is, how many 5-digit PINs are there if the PIN cannot have repeated digits? So a PIN is a personal identification number. That's what that means. And a 5-digit PIN would be one where you have 5 numbers in your PIN. And if the PIN cannot have repeated digits, that means that whatever digits we choose first will impact which digits we can choose second and third and fourth and so on. So in this problem, we have 5 events that are happening, or 5 choices that are being made, because we're choosing our 5 digits. And the first digit has 10 possible options that we could choose, because we could choose the number 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9, but we could also choose the number 0. So there's 10 possible digits that are options for us to choose our first digit of our PIN. So we have 10 possibilities for the first one, but the second one only has 9 possibilities because whatever we choose first cannot be repeated. And so we can't have it be the next digit. So like, let's say I chose a 5. Well, in that case, I could choose 1, 2, 3, or 4, or 6, 7, 8, 9, or 0. So there's 9 possible outcomes for the second choice. Then the third choice will only have 8 outcomes, or 8 options, because you don't want it to be any of the digits you've already used in the first 2. And then the fourth one will only have 7 options, and the fifth digit will only have 6 options. And so I could multiply those out, 10 times 9 times 8 times 7 times 6, or I could use the NPR button and do 10 NPR 5 because I'm choosing 5 numbers, and that would be 30,240 different possible pins that I could have. And the notation for that, if you want to write that in formula terms, that would be 10 to the 5 falling. And that's how you would calculate that. For this second question, it says, how many ways could you choose a president, vice president, and secretary from a group of 24 people? So in this case, we have 3 choices that we're making, 1, 2, and 3. And our first choice could be any one of the 24. So I could choose my president from any one of the 24 people. Then my vice president could be any of the 23 remaining people that's not the president that I already chose. And then the secretary could be any of the 22 people who are not the president or vice president. And so the formula form of this would be 24 to the 3 falling. And we could calculate that out by multiplying 24 times 23 times 22. Or I could use the permutation button and do 24 NPR 3, which gives me 12,144 ways that I could choose a president, vice president, and secretary from a group of 24 people. So that's how you would do that problem. And then on this one, if we're looking at how many ways you could choose a 7-day menu from the 16 unique meals in your freezer, in this case, we're making 7 choices because we're choosing a meal for each day of the week. So we'd have 7 choices. And our first choice has 16 options because we could choose any of the 16 meals we have in the freezer. Then the meal we choose for the second day could be any of the 15 meals that we didn't eat the first day. So our first choice eliminated one of the options for our second choice. And then our third choice could be any of the 14 remaining meals. The fourth choice could be any of the 13 remaining meals, 12, 11, and 10 for the last meal. And when you multiply all those together, 16 times 15 times 14 times 13 times 12 times 11 times 10 ends up giving you a very large number. I think that's 57,657,600 possible ways that you could choose a 7-day menu from the 16 meals in your freezer. And the formula form of this would be 16 to the 7 falling, because we had 16 multiplied by, there were 7 numbers total multiplied, and they started at 16 and then counted down from there. So that's how you would do that one.